Hi students, in this video I'll be covering test number 1 review, starting with just problem 1 for this video. So here on your graph we're given the graph of a line. You can see all the ordered pairs are listed. I do recommend that you go ahead and write a table of all these values. We're going to use those later. So for part A here, you're asked to evaluate f of negative 2. That requires you to understand that f of x is equal to y. So just like here in parentheses, you see a number, here in parentheses you see x. So negative 2 is your x value. So what you are asked to do is basically look at the ordered pair when x is negative 2 and determine what is your y value. So if we look over here on our graph, when x is negative 2, if we go down to our line, we have the point negative 2, negative 1. So therefore negative 1 is our answer. F of negative 2 equals negative 1. Next you're asked to evaluate and find x when f of x is equal to 3. Remember up here f of x equals y. So just come down here if it helps and put y equals 3. So that means when y equals 3, what is x? So if we look here on our graph, when our y is 3, we have an x value of 0. So that's just 0. Next, we're asked to evaluate f of 9. Well, we don't have f of 9. So, because on our graph it only goes to 6, so we can't see way up where it's 9. So if you wanted to, you could graph it and continue your slope until you get to an x value of 9. That's one way to go about it. Another way to go about it is to type this in your calculator and in L1 and L2, and then do stat calc 4. I don't have a calculator with me, so you're going to have to do that on your own. Remember to go to stat, hit enter, put your x's in list 1, y's in list 2. When you've completed that step, press stat, arrow right to calculate and choose number 4, arrow down to the word calculate and hit enter, and you'll get the equation y equals 2x plus 3. So there's a couple of ways to now evaluate f of 9, the easiest of which is to simply plug it in for x. So now that we've got the equation, we can just do 2 times 9 plus 3. 2 times 9 is 18, plus 3 is 21. You could also go to y equals and type in 2x plus 3 and look at your table. Or you could store negative 9 as your x value, and then on your home screen type in 2x plus 3, and you would also get 21. But this one is a simple one to do algebraically. Next for D, it says determine the rate of change on the interval from negative x to negative 2 to 4. So if you look, what that means is what is our rate of change from negative 2 to positive 4. So we don't see all the way up there, but what we're trying to do is find the rate of change between those 2 points. So my recommendation would be to create an XY table where your input values are negative 2 and 4, because it says x is in between negative 2 and 4, and find the output values. Now we can look here on our graph and say, well, when x is negative 2, y is negative 1, or we can go to our table on our calculator when we input 2x plus 3 into y equals. When we do that and we look at our table, or plug it in here into our equation 2x plus 3, we would find out that our y value is 11. So in other words, we could do 2 times 4 plus 3 by plugging it right up into here. 2 times 4 is 8, 9, 10, 11. That's where we get 11. So when we're asked to find the rate of change, remember your rate of change always means the change in your y value divided by the change in your x value. So what I want you to do is simply compare. Think about the number line that's hanging on the top of my classroom. If we have a value of negative 1, which is to the left of 0, and we're looking at how does it change to get to 11, you would find that you actually have to add 12. So if you want, you can also do 11 minus negative 1. But if you just think about the number line, to go from -1 all the way to 11, you'd have to add 12. To go from -2 to +4, you would have to add 6. So remembering that your change in y over change in x gives you your rate of change. Your change in y, it changed by +12, and your change in x was 6, and 12 divided by 6 is 2. All right, next for E, it says predict what the rate of change will be on the interval from 5 to 6 and explain. Well, what you should notice is that with a linear function, as we have graphed here, the rate of change is constant. So if you pay attention here, what you should have noticed is that here my rate of change is 2, because that's my slope. I did calculate here that the rate of change was 2 between the points where x is -2 and where x is +4. And also, we could count rise over run, and notice, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So what we can predict the rate of change will be is it will always equal 2. Why? Because the rate of change for a linear function is constant. So we don't necessarily have to calculate, although we could, and if we did, we would still find that out that it equaled 2. So that concludes number 1. I'll do another video for problems 2 through 5, or 2 through 6 rather.